Hello, this time we're going to check for linear independence. So, is this collection that we have here a linearly independent set of R2? Well, to do that, let's start with the following. Let A1, A2, and A3 be real numbers. And suppose that A1 times 1, 1 plus A2 times 1, negative 1 plus A3, 2, 3 is equal to the 0 vector. The question, right, it's whether by keeping this assumption we get to the conclusion that A1, A2, and A3 are all 0. We don't know, right? But what we know is that we can transform this into an equivalent equation, a system of equations. What would be that system? Well, this one. A1 plus A2 plus 2A3 is equal to 0. A1 minus A2 plus 3A3 is equal to 0. But now this turns into a matrix form, right? So that it's now prone to reduction. 1, 1, 2, 0 in the augmented part. 1, negative 1, 3, 0. You see? This one corresponds to that column. This one corresponds to that one. This one to this one. And this one to this one. And now we start with the reduction process. So to R2, the second row, we subtract the first one, as now this is a pivot, right? Gaussian elimination, right? Nothing new under the sun here. 1, 1, 2, 0, 0, negative 2, 1, 0, right? Then from here, next elementary row operation, negative 1/2 of row 2, and we have 1, 1, 2, 0, 0, 1, negative 1/2, 0. Then from here, boom, next operation. To row number 1, we subtract row number 2. And we obtain 1, 0, 5/2, 0, 0, 1, negative 1/2, 0. Now, we recapture what the system indicates. So this says that A1 plus 5/2 of A3 is 0. And that A2 minus 1/2 of A3 is 0. Of course, we can rewrite this into an equivalent form, that is A1 is equal to negative 5/2 of A3, and that A2 is equal to 1/2 of A3. Now, look, this actually is exhibiting a dependence of these coefficients, right, in terms of this one. So I don't think that the collection is going to be linearly independent, but let's be very concrete. Note that A3 can be anything. In particular, it may be 2. Why not? So, if A3 is 2, then A1, it's negative 5/2 times 2, which is negative 5. And A2 is going to be 1/2 times 2, which is 1. So, what does this mean in terms of the original equation that we started with? Well, we have found the following. A1, which is negative 5 times 1, 1, plus A2, which is 1 times 1, negative 1, plus A3, which is 2, times 2, 3 is equal to 0, 0. Note that not all of -5, 1, and 2 are all 0. And I have to stress that part, all, right? In fact, none of them are 0, right? Conclusion. Then the collection is not linearly independent. So that's how we can develop a method. Let's try with another set. So it becomes a complete demonstration. Right? Is the set containing the vectors 1, 1, 0, 1, -1, 0, 0, 0, 2, a linearly independent set of R3. So that's the second question. Right? Well, who knows? We'll start just as before. Let A1, A2, A3 be numbers such that we have A1, 1, 1, 0 plus A2, 1, -1, 0 plus A3, which would be 0, 0, 2 equal to 0, 0, 0, the vector. Now, look, we need as many coefficients as we have vectors in this collection, right? So we transform this equation into an equivalent system of linear equations. And what would that be? Well, I'll write it just here. So we have that A1 plus A2 is 0. We have A1 minus A2 is 0. And we have that 2A3 is 0. Now, to keep things in the same way that we have done it before, we're going to turn this into a matrix. Right? Where the columns are exactly the vectors, right, that we have here. So that would be 1, 1, 0, 1, -1, 0, 0, 0, 2, 0, 0, 0. We start with the reduction process in order to gain understanding about the solution to this system. So we have row 2 minus row 1. Now it turns into 1, 1, 0, 0, 0, -2, 0, 0, 0, 0, 2, 0. Next, next operation, -1/2 of row 2. So our matrix becomes 1, 1, 0, 0, 0, 1, 0, 0, 0, 0, 2, 0. Next, to row 1, we subtract row 2. And now we have 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 2, 0. Lastly, to row number 3, we multiply it by 1/2. And we get the following matrix: 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. Now, we interpret this matrix as a system, but that system says A1 is 0, A2 is 0, and A3 is 0. So each of A1, A2, and A3 is 0. Thus, the collection is linearly independent. So what we have done is that we developed a method, right? We start with a collection U1, U2, UK. From this one, we establish a system, A1, U1 plus A2, U2, AK, UK equal to the zero vector. Form a matrix, right? Row reduce in echelon form. Right? And then from here, interpret whether the associated equivalent system has a unique solution or not. If it has a unique solution, well, that solution is the homogeneous one, meaning that all the coefficients here should be zero. If it doesn't have a unique solution, well, that means that you can find some linear combination where not all the coefficients are zero, for which this equation holds, meaning that the entire collection is not linearly independent, meaning it's linearly dependent. Okay, I hope that you like it, and take care. Subscribe and set your request. See you next time.